Or just a peace sign.
Alright, 11-1.
Sorry, I got landscaping.
Parabolas. You guys remember what a parabola is?
Isn't it the...
Yeah. Okay, so I'm going to go over just some basic stuff to make sure we kind of remember what's going on, just to remind you some basic things. So, a parabola comes from our basic trinomial, ax squared plus bx plus c. Anytime you have a squared term, it's going to be parabolic shape, and the other variable is not. Okay, so you got to kind of, we'll just call this a linear term because it has an exponent of 1. But some things that we've been taught about parabolas is the coefficient on the x squared term. That tells if it opens up or down. C gave us the y-intercept where it crosses the y-axis. You guys remember this at all?
Yes.
And then B, we use B to get the axis of symmetry, negative B over 2A. And the axis of symmetry is the invisible line that goes through your vertex, where you could fold the parabola over onto itself. Make it symmetrical. The symmetry line of symmetry. Okay, so that's the basic stuff. You're not always given B. Sometimes C is not even there. Sometimes you're just left with y equals x squared. But then there's some other things that you've been taught. Let's just do the basic part. Y equals x squared. That is a vertical parabola. And then we have x equals y squared, which is horizontal. You haven't really dealt a lot with that, but all the things apply, except it's on its side. Okay, so A still, for the vertical, if it's positive, opens up and down. If it's positive here, it opens to the right. If it's negative, it opens to the left. And then we go on and we learn some more things that you learned in Algebra 2. Okay? So let's just draw a basic parabola and label some things that you're going to have to do. So we're going to start with a vertex at the origin, and today's lesson is they're all at the origin. Okay? When we move them, that changes some things. But as of right now, the vertex will be at the origin. There's some things we got to know. So we'll call this the focal point. You got to give me the coordinate of the focal point and tell me what it is. We have a thing down here called Directrix. You got to give me the equation of the Directrix in your problem today. So there's 3 things you got to give me. 1, the focal point, the coordinate. 2, the Directrix. 3, distance through the focal point to the other side is called the focal diameter. And that's the distance from one side of the parabola to the other through the focus. So those 3 things you got to give me. Now, there's some things that will help you go through this. Number 1. Solve for the linear variable. That means the linear variable needs a positive 1 coefficient. That's key. Number 2. 4p equals, solve for the linear variable, and the squared term has to be positive 1 coefficient. So we're going to write the coefficient on the, we'll say x squared term, must be 1. If it's y squared, then it's y squared, okay? So the squared term has to be a positive 1. You're solving for your linear variable. I'll show you an example here in a minute. Make sure the squared term has a positive 1 coefficient. So step 2, set 4p equal to the coefficient on linear term. Right now, none of this really makes any sense to you. You're just writing down the steps, okay? But once you go through this, it's very, very simple and easy to graph. We're going to graph today. Can you solve for p at that point? Set 4p equal to solve for p. 3, you're going to find the focal or the focus, the coordinate. And 4, you find the directrix. And 5, the focal diameter, which is a number, making a distance. Diameter is a distance. But you can't do those last three things unless you do the first 2. All right?
You probably don't have them right now, but just let me know if you do or not, please.
Last hour.
Yeah, they've done that to like 17 of these, so
That's all right.
that's okay then. Thank you.
Yep. All right, so those 4 things you're going to need to do today. All right, so let's do a simple example here. So we'll start with the basic y equals x squared. Okay? Step 1, solve for the linear variable, which we have here. That's the linear variable y. It is solved. Make sure the coefficient on the squared term is a 1. It is. Step 2, set 4p equal to the coefficient on the linear term. Solve for p. So you can write that in there. Solve for p. So p equals 1/4. Alright, so as soon as you caught up, we'll go back to that diagram. If you want to know where 4p comes from, there's a good explanation in the book of how it's derived. It's just a formula that we're going to use, so you can look in there and see how it is. So we go back to this picture here. This distance from the vertex to the focal point is p. And the distance from the vertex to the directrix is p. Good so far? Now, this distance is 2p. This distance is 2p. So what's the total distance? 4p. What's 4p equal? In this problem, but what do you set it equal to? The coefficient on the linear term. So the focal diameter is 4p. Okay? So that's just the visual behind what we're doing. If the vertex moves and you need to know where the focus is, you're going to add p to wherever the focus is. Alright, so that was step 2, solve for p. Step 3, the focus. So let's draw a picture to make sure we understand what's going on. First of all, is this a vertical parabola or a horizontal parabola? A vertical parabola. Does it open up or down?
Up.
Up. And the vertex is at the origin. So if the vertex is at 0, 0, what is the coordinate of the focal point? Zero p. So you put that in here. 0p. That's not always 0p, okay? It all depends on where the vertex is really at. Alright, for the directrix, it's going to be down here. And the directrix is the equation of a line. What axis does it go through? The y-axis. So it's y equals, what is this point here? Negative 1/4. Okay, so this is 1, that's 1. not going to draw this exact yet. Okay. We just know it opens up. Now 5 is the focal diameter. And what is that? What's the value? Which it was in? What's 4p equal to? 1. So it's the distance. Okay, now watch. Visually watch what this is. So it's from one side of the parabola to the other. So from the middle to the other side, we're at 1/2. Right there, and the other side is at 1/2. So this helps tell you at the beginning what the shape is starting to look like. But everybody knows that y equals x squared goes through 1, 1. So it helps decide whether or not it's fat, skinny. Everybody in here can make an XY chart and plot points and figure out exactly what it looks like. But you've been taught how to do factoring to find zeros, and completing the square and quadratic formula. Those are all how to find where it crosses the x-axis. You were taught how to find the vertex by the axis of symmetry. And now in Algebra 2 and in PreCalculus, we're talking about the directrix and the focal points. And we're going to do more with this stuff, but as right now, this is the beginning. All right, so let's do another problem. We'll make it harder. Okay? X minus 7y squared equals 0. Follow the steps. So this is the first half of section 1 of what we're doing. Follow the steps. You should be good. If you don't memorize the steps, then you won't be good on the quizzes or the tests. Yeah.
Can we put them on our cheat sheet?
The steps. Why don't you wait until you're done with your homework? My guess is you might. I mean, you put. I don't care if you put them on there, but I don't think you really need them all.
Okay.
My guess is after you do your homework, you can probably narrow it down. That's okay. As long as there aren't any numbers on it. You just can't have your notes on your reference sheet. You do have to study. Okay. I'll do step 1. You should be done with it by now. So that's what step 1 is. Get the y squared term by itself with a positive 1. So we solved for the linear term, then we got the squared coefficient to be a 1. This is how you should do it.
Why can't you just leave them as 7?
Because this position is what 4p equals. This has to be a 1 to identify 4p. That's why you have to do step 1 that way. Okay? Step 2. 4p equals 1/7. And here's where we lose some of you. Did you divide by 4? So you get the top times the reciprocal of the bottom. P is 1/28. Right? Again, you're going to have to deal with fractions. Okay? Moving on. Visually, we just put this up here. Is this a vertical parabola or horizontal parabola? Horizontal. Which way does it open? A is positive here, so it opens to the right. So it's going to go like this. 1/28 is really small, so that means 1 must be way out here. So the focal point, the focus, is what? Raise your hand. What's the focus?
0.
Yep. 0. No, I'm sorry. 0. Alright, so we're on the x-axis now. Okay. Directrix. What axis does the directrix go through? Goes through the x-axis. Where?
Negative 1, 8.
At negative 128. Focal diameter. Plus 4p. Say it loud if you know what it is. What's up? That's my focal diameter. The distance. If you do the first 2 steps, then the rest of this should be, and start to draw it, then you should be able to get through it pretty quickly. After you do a few of these, it should catch on. Okay, so we're going to split section 1 into 2 days. So today's assignment deals with just this stuff. Tomorrow we're going to work this backwards. Page 730, 5 and 21 odds. Begin. All right.
Right here.
Yep.